Alright, let's wrap up this code. This will be part 5. Alright, so now the last thing that we need to do for this code is to solve for t. So we can define a new function. We can call this just EQS. Our variable is vector. We're going to assign t to this vector. There we go. Now we want to return something we haven't quite seen yet. This is actually going to be just need to be an array. Yes, it does. Okay. NP dot, which is the dot product of two arrays. So it's a scalar function, and it you can Google it. It's a long explanation. I can't really off the top of my head. But we are going to call back to our enthalpy function that we created earlier, and that is we're going to do moles going out, and then that is going to be subtracted by NP dot of our steady state temperature, enthalpy rather, and that is times moles going in. Now we can use root to pull out the solution, pick the right function, and then we just need to give a guess. I think in class we did 2000. Let's pull out the last one because that's the answer. And that is not the right answer. So let's figure out what we did wrong. That's good. That's good. That's good. That's good. 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 Oh, there's one. This should be multiplied. Multiple. Alright, does that fix it? That's not right either. It should be like 2063, I think. Degrees Kelvin. No. That should be the no, yeah, degrees Kelvin. That's what we're figuring out with the temperature. So what else is there? All these are spelled right, are they? Yeah. Just referencing over here. Okay, this doesn't feel right to me. This does not feel right. So let's go back and make sure that's correct. I think we still have it pulled up. We do. Oh, it's not. Look at that. Don't know how I screwed that up that bad. Alright, so this should be times tangent h times e over t. Let's go back and fix that. I think I just have to switch this. There we go, that's the answer. So, little rundown. See if I can, my best explaining voice out. Here we go. So, we started, down here still, we started by stoichiometry, balancing our combustion reaction. We then figured out that since the temperature is changing, that means the enthalpy will be different for going out. Therefore, we need to look at the heat capacity. We related the heat capacity to the change in enthalpy is equal to the heat capacity times the change in temperature. We then derived that. We figured out we needed to take the integral of both sides. We found an equation for that, we then integrated that equation. We found an equation for the heat capacity in relation to temperature. We then integrated that that formula. We pulled out the variables from chem tools. We then used this equation to find out the difference in the enthalpy of formation. We then found our mole ratios, and the moles going in and the moles coming out. We then, which is right here, and then finally we solved for temperature, and we got the temperature leaving, the temperature of the flame is 2063 degrees Kelvin. Thank you.